Good morning all. This is mathematics class of grade 8 and this is my lecture number 4 of chapter number 14, Factorisation. Coming to today's topics, what we will be discussing in this lecture number 4. First of all, we will recall the concept of factorization of trinomials in which the factors are of the form x plus a into x plus b. And then we will be covering the topic of division of algebraic expressions, and under this topic I will be explaining the subtopic, that is division of a monomial by another monomial. So first of all, what we will be doing, we will be recapitulating the concept of factorization of trinomials in which the factors are of the form x plus a into x plus b, and then I will be explaining the topic of division of algebraic expressions, how to divide algebraic expressions, and under this I will be explaining the division of a monomial by another monomial. So let us recall first. Factorization of trinomials, that is in which the factors are of the form x plus a into x plus b. Dear children, when the trinomial, all of you know what do you mean by a trinomial? It is an algebraic expression in which number of terms are 3, or an algebraic expression having 3 terms is known as trinomial. So when the trinomial is of the form x square plus px plus q, where p and q are integers, and for this I am taking x square plus px plus q equal to x plus a, x plus b, because it is the topic only factors are of the form x plus a, x plus b. And when I will be dividing these two binomials, I will be getting this. Now next step is you need to compare this x square plus px plus q, one expression, to x square plus a plus b into x plus ab. Now after comparing, you will find that coefficient of x, what is the coefficient of x? This is p. It is equal to a plus b. In place of p, what is written? A plus b on this side. Now in place of q, what is written? ab. So this is also called splitting the middle term. We need to express p as the sum of two integers, and q should be the product of those two integers. That is, thus if we want to factorize the trinomial of the form x square plus px plus q, we need to find two integers ab such that a plus b is equal to p and ab is equal to q. Therefore, split p, that is the coefficient of x, into two parts such that algebraic sum of these two parts is p and their product is q. That is what I have explained in the previous slide. So you need to split p, that is the coefficient of x, into two parts such that algebraic sum of those two parts is p and their product is q. That is, a plus b should be equal to p and ab should be equal to q. So let us understand this with the help of an example. Here I have taken an expression, that is z square minus 4z minus 12. Now, dear children, as you all have seen that I have compared the expression, that is x square plus px plus q, to x square plus a plus b into x plus ab. So what is q here? This is minus 12. So the product of the integers, that is ab, should be minus 12. And the sum of those two integers should be minus 4. So this means that one of a and b should be negative or is negative. So and a plus b should be equal to minus 4 and ab should be equal to minus 12, and one of them should be negative. And which one should be negative? the larger numerical value should be negative. Then only we will be getting minus 4z as the answer. So, if we will try a is equal to minus 4 and b is equal to 3, but that will give you a plus b is equal to minus 1 in that case. You will be getting, if I will try minus 4 into 3, you will be getting minus 12, but the sum or the difference of these two numbers should be equal to minus 4. So, these two are not the required integers. Let us talk about a is equal to minus 6 and b is equal to 2. So, let us see. We need to find two integers whose sum is minus 4 and product is minus 12. This I already explained. Then by trial, as I told you, we can take we have tried it with the numbers that is minus 4 and 3, but that is not satisfying the condition of that a plus b should be minus 4. This condition was not satisfied in this case. So we have tried the two numbers as a is equal to minus 6 and b is equal to 2. After solving, you will be getting minus 4z, and after multiplication of these two numbers, you will be getting minus 12. So, the required values of a and b are minus 6 and 2 respectively. So, a is minus 6, b is 2. So, in place of minus 4z, we need to write these two numbers. And in place of 12 will be written as it is, because these two numbers will be written in place of p only. So therefore, z square minus 4z minus 12 will be equal to z square, as we have seen that these are the two required numbers, the values of a and b. So minus 12. Now we need to do the grouping of terms. Now this is one group and 2z minus 12 is another group. So z square was present, z is present with 6. So 1 times z, that is z is taken out, and what will be left inside the bracket? Z minus 6 plus what is the common factor of 2 and 12? That is 2 written outside. What will be left inside the bracket? Z minus 6. So z minus 6 is present along with this term. Here also it is present. So z minus 6 will be written one time outside. And what will be left? Z plus 2. So these are the two factors of this expression. Now coming to the main topic of this today's lecture, that is division of algebraic expressions. Under this division of algebraic expressions, I will be explaining the division of a monomial by another monomial. And dear children, all of you are aware that division is the inverse operation of multiplication. All of you know this, that division is the inverse operation of multiplication. We have learned how to add and subtract the algebraic expressions. We have learned how to multiply those two expressions. Now, let us look at the concept of division of algebraic expressions. And division is the inverse operation of multiplication. For example, 7 into 8 gives 56. And if I will be dividing 56 by 8, I will be getting 7. Or if I will be dividing 56 by 7, I will be getting answer as 8. So we can say that division is the inverse operation of multiplication. From this example, you can understand it. We may similarly follow the division of algebraic expressions. In the same manner, we need to do the division of algebraic expressions. Now, I am taking an example. This is the multiplication of two monomials, that is 2a into 3a square. 2 into 3 will give you 6. A raised to the power 1 into a raised to the power 2 is a raised to the power 3. So therefore, if I will be dividing 6a cube by 2a, then I will be getting answer as 3a square. And if I will be dividing 6a cube by 3a square, what will be my answer? 2a will be my answer. So this is 6a cube divided by 3a square, you will be getting 2a. Now let us see the examples. I have taken two examples, that is, do the following divisions. This I am explaining with proper steps, but you are supposed to write the answers directly. And these steps you may do in the main steps. You may do in the main sheet, on the main sheet, but if you are doing like this, that is also sufficient. You can do like this also, in this manner also, and you can do like this, which I will be showing in the next slide. You can do in that manner also. Okay, so it is minus 20 a raised to the power 4 divided by 10 a raised to the power 2. Basically, when you need to divide two algebraic expressions, you need to factorize those two terms or those two expressions in the numerator as well as in the denominator. I am showing it separately first of all, and then I will be dividing. So minus 20 a raised to the power 4 will be written like this: minus 2 into minus 2. What are the factors of minus 20? It will be minus sign will be written. 2 into 2 into 5. A raised to the power 4 was there, so 4 times I have written a. Next term is 10a square. So what are the factors of 10? 2 into 5. A square was there, so it was written twice. Now this step, as I told you, you can do it or you can do in the rough sheet, on the rough sheet, but this, if you are writing it, that is also correct. Here the main part of the question starts. This is what I have written. This is what we need to divide. Now you are supposed to write the factors of this first term like this in the numerator, divided by factors of this 10a square in the denominator. Now I need to divide. Now how will you divide? This 2 will get cancelled out with this 2. 5 will get cancelled out with this 5. A square will get cancelled out with this a square. What you are left with now? Minus 2a square. This is what I have written here. Minus 2a square. That will be your answer. Now coming to this second example. In the second example, I have not shown you the factors of this. You can show or you cannot show. It is up to you now. 7a square b square c square, this is your numerator, and you need to divide it by 14abc. You can cancel out 7 and it will be 2, so I have written 1 by 2. A raised to the power 2, it was in the a raised to the power 2 is in the numerator, a raised to the power 1 is in the denominator. Then what will be left with us in the numerator? It will be a raised to the power 1. Likewise for b and c, it will be b raised to the power 1, c raised to the power 1. So dear children, in this lecture, first of all, we have recalled the concept of factorization of trinomials, in which the factors are of the form x plus a into x plus b. Then we have learnt the division of algebraic expressions. Under this, I have explained the subtopic, that is division of a monomial by another monomial. Basically, while doing the division of algebraic expressions, you need to factorize numerator as well as denominator, and the for factorization we have learnt 4 methods. You are supposed to use any of those 4 methods according to the requirement of the question, and we will be covering a few examples in the next lecture. Then it will be more clear to you how to do or use the factorization methods for division of algebraic expressions. Now coming to the homework part, you are supposed to complete question number 2 and question number 3 of exercise 14.2 in your homework notebook. Few students, they have covered question number 2 and question number 3 of exercise 14.2 in homework notebook. You are supposed to complete these 2 questions, and apart from those, I have given this homework for the previous lecture, but some of the students were not able to complete it, so I have written it again. So complete question number 2 and question number 3 of exercise 14.2 along with question 4 and question 5 of exercise 14.2. You are supposed to complete basically these 2 questions of exercise 14.2 in your homework notebook. These 2 questions, I think you must have done it, and I will be discussing the solution of these 2 questions, and your main homework is to complete question number 4 and question number 5 of exercise 14.2. Let us see the homework solutions from NCERT exercise 14.2. You need to factorize. Question 2 is you need to factorize. I am showing you the parts which I will be discussing. These are the parts which I will be discussing. That is, first part 4p square minus 9q square. Likewise, I will be explaining the parts to you. This was the another part which was left to be written on the screen. So all these 5 parts I will be explaining from question number 2. Let us move to first part solution. Here, as you all know that this is a square and this is also a perfect square, and these there we have the difference of two squares, then we need to use identity number 3. We are supposed to use identity number 3 here. So 4p square can be written as 2p square, 9q square can be written as 3q square. So a square, a here is 2p, b here is 3q, a square minus b square is equal to a plus b, a minus b. You are supposed to mention the identity along with every question, like I am explaining everywhere. I am writing the identity everywhere. So likewise, you are supposed to mention the identity which you are using in the question along with every part. So this is what I explained. Coming to solution of second part. Now, dear children, if you analyze this question, 63 and 112, these two are not perfect squares. A square or b square, it is fine. So what we can do, you need to take something common out, then they can be perfect squares. So 63 and 112, I have taken 7 common out of them, and now what will be left inside the bracket? 7 into 9, 63. So it will be 9a square minus 16b square. So now these are perfect square. So we have the difference of two perfect squares, and we know that which identity we are supposed to use? Identity number 3 we will be using again. So this will be the identity. Now here it is, 9a square can be written as 3a square. 16b square can be written as 4b square. So your a is 3a, b is 4b. If you are getting confused with this a and b, you can write x and y also. In terms of x and y, you can write the identity. So it will be x square minus b square, that is x plus y, x square minus y square, that is x plus y into x minus y. 7 will remain outside. So using identity a square minus b square is equal to a plus b into a minus b, taking a as 3a and b as 4b. Or if you are getting confused, as I told you, you can write this identity in terms of x and y also. In place of a and b, you can write x and y also. Now solution of fourth part is, similarly, this is not a 16 is a perfect square, we agree. X raised to the power 5 and x raised to the power 3. We cannot solve this until and unless we can take something common out. So 16 and 144, from these two numbers I am taking 16 common outside. X raised to the power 3, x raised to the power 5. So minimum power of the variable to be taken out. So x raised to the power 3 along with 16 I have taken out. What will be left inside the bracket? 16 was already out. So what is left inside the bracket? X raised to the power 2 minus 9. And now these two are perfect squares. And now we can apply identity number 3. So it will be x square minus 3 square, which what is it equal to? X plus 3, x minus 3. So this will be according to the identity number 3. We have used identity number 3, a square minus b square, that is equal to a plus b, a minus b, taking a as x and b as 3. So it means if directly you are not able to apply any identity, after taking any factor common from those terms, you can apply the identities. Now if we talk about this question, solution number 7, this is what, can you analyze this and compare it with the right hand side of identity number 2? Yes, it is a square minus 2ab plus b square. So what I can write in place of this? X minus y square. Can I write like this? In place of this, can I write this? Yes, definitely, because we have read that this is identity number 2. So I have written like this using identity number 2. This is what I told you. Now if you analyze this step now, these two are perfect squares and their difference is given to us. Now which identity we will be applying? Third identity, that is a square minus b square. Now a here is equal to x minus y, b here is equal to z. So Using identity number 3, a square minus b square is equal to a minus b, a plus b. Taking a as x minus y, b as z. This is what I explained. Now, what is it equal to? A, this was a plus b. This was a minus b. So, this is your answer. Coming to the solution of 8th part, that is 25a square minus 4b square plus 28bc minus 49c square. Dear children, if you observe this or analyze this question, this is a perfect square, this is a perfect square, and this is also a perfect square. But we have one more term that is consisting of b and c variables along with it. So what we can do is, if you observe this part only, this part of the question, can I apply identity number, any identity in this? Because this is a perfect square, this is also a perfect square, but there is a difference of minus and plus sign. है ना? So what we will be doing? We will be taking minus sign common out of this. So what I have done, I have changed the sign. Minus sign I have taken out. It will remain 4b square. Minus minus, it will give you plus 28bc according to the previous step. Now it was earlier minus sign. I have taken minus common or minus outside. So it will be plus 49c square. Now can I apply identity number 2 for this part? Yes, definitely I can apply identity number 2 here in this part. 2 squares in between and minus 2ab is with us. So we need to apply identity number 2 for this part. And what I have done now, 25a square can be written as 5a square. Now 4b square I have written 2b square minus 2. A here is 2b. B here is 7c. 7c 2ab plus b square. So what is it equal to now? A minus b whole square. This was our a, this was our b, so a minus b whole square. Now if you look at this step, difference of two perfect squares are with us. Now can I apply identity number 3 again? Yes, I can apply identity number 3 here again. This was the explanation. This is the identity which we have used for this step. This is the identity which we have used for this step. That is identity number 2. Now for the last step, I need to use identity number 3. X square minus y square, x minus y, x plus y. So taking x is equal to 5a, y is equal to 2b minus 7c. It will be a, x, in terms of x and y I have written. So you can take x plus y. This is x minus y. This is y, this is x. So here can you see minus sign outside? So this minus sign which is inside the bracket will be changed to plus sign. So it will be 5a plus 2b minus 7c, 5a minus 2b plus 7c. So this will be your answer. So you must have seen that in few questions we need to apply two identities. So you can do so. It is not mandatory that you will be using only one identity in one question. Now question number 3 is factorize the expressions. Now I am directly writing the answers. By the time you are supposed to do a lot of practice to write down these the answers in this manner. So what I have done, 7p square plus 21q square, out of 7, what is the common factor of 7 and 21? 7. Can I take any variable common out of p square? Here it is p square, here it is q square. No, I cannot take anything common. So 7 was the common factor of 7 and 21. So it is written outside the bracket. In the bracket, what is left for first term? P square. What is left for second term? 7 into 3 will give you 21. So 3q square. So this will be your answer for the second part. Now coming to third part. Here, if you observe these three terms, what can you take common out of these three terms? So let us see the answer now. 2 is present everywhere. So 2 I have written. X cube, x raised to the power 1 and x raised to the power 1. So as I told you that minimum power of the variable is to be taken out. So x raised to the power 1 I have taken out. What will be left for this term? X square. What will be left for second term? Y square. What will be left for third term? Z square. So this will be your answer. Coming to seventh part, that is 5y square minus 20y minus 8z plus 2yz. So if you observe this, from all these terms, I cannot take all together any common factor from all these terms. So we can use the method of grouping of terms. We need to make the grouping of terms, and as I told you that number of terms, if number of terms are even, you may use grouping of terms, but it is not mandatory that every time you will be using that grouping of terms. Okay, so here we will be using grouping of terms. Now we need to make the groups. So this was the part given to us. Now what I have done, I have made the grouping of these two and these two. So this is one group, this is another group. So here what I have done, I have shifted this 2yz first and minus 8z I have written afterwards. This is this I have done so that you can understand that as I need to make this factor same, y minus 4, then so that that is why I have written plus 2yz minus 8z before minus 8z from this step. If from 5 and 20, what is the common factor? 5. Y square and y raised to the power 1, y we have taken out. What will be left inside the bracket? Y minus 4. Plus what is the common factor of 2 and 8? It will be 2. Yz, y is not present in this term but not here, so we cannot take common. Z raised to the power 1 here, z raised to the power 1 here, so z taken out. What will be left inside the bracket? Y minus 4. So what will be the factors? It will be y minus 4 bracket 5y plus 2z. So I hope, as I told you, that this factor should be same, and it means our grouping is correct. That is why I interchange their positions. It hardly matters because I can write plus 2yz before minus 8z also. So your answer is y minus z bracket 5y plus 2z. Now this eighth part is 10ab plus 4a plus 5b plus c. Now here again, okay, what I have done here is I have done the grouping of 10ab plus 5b plus 4a plus 2. After this step you need to write down. 10ab plus 5b, this is your one group, and 4a plus 2, this is your another group. After this step, you can easily write this step. What is the common factor of 10 and 5? That is 5. A is present here, but A is not present here, so we cannot take common out. B is present in both the terms, so it is taken out. What will be left inside the bracket? 2a plus 1. Now, out of what is the common factor of 2 and 4? 2. A is present here, but A is not present here along with this 2, so it will not be taking out. 2 only will be taking out as the common factor. So what will be left inside the bracket? 2a plus 1. Now this is same, 2a plus 1, this is 2a plus 1, so our grouping is correct. So what will be the factors now? 2a plus 1 into 5b plus 2. So these two are the factors of the given question. Now coming to ninth part, it is 6xy minus 4y plus 6 minus 9x. What I have done, I have made the grouping of 6xy minus 9x. I have made their groups, and these two I have taken into one group. If you may be thinking that why we have not taken these two groups, these two together. You can try it and tell me or get to know that whether the answer will be same, or we can, sometimes it may happen that my the groups which I have made may not match with your group, but answers may remain the same. It is not mandatory that every time you are supposed to, like in this part, you can do the grouping of 6xy minus 4y also. Answer will remain the same. And another part that you can verify that grouping is correct or not, this part which is present inside the factor, which is present inside the bracket, this factor which is present inside the bracket should be same, then you will come to know whether your grouping is correct or not. So what we have done, 6xy minus 9y I have taken into one group, minus 4y plus 6 I have taken into another group. So what is the common factor of 6 and 9? It is 3. X is present over here. Here also it is present. So we have taken x one time out. Y is present along with first term, not with the second term. So it is not a common factor. So 3x is the common factor. What will be left inside the bracket? 2y minus 3. Now, what is the common factor of 4 and 6? That is 2 minus 2 I have already taken out. It will be 2y. What will be left inside the bracket? 2y minus 3. Why I have taken minus sign here? The reason being because minus will give you plus, and I need this plus sign. So if I will be multiplying minus 2 into minus 3, I will be getting 6 plus 6. So that is why I have written minus sign along the inside the bracket. So the factors are 2y minus 3, 3x minus 2. And you can try the grouping of 6xy minus 4y and 6 minus 9x. You can try the grouping of these two groups also. So I hope you must have understood the concepts taught in this lecture, and you will be able to complete your homework from NCERT book. Thank you so much.